Hello and welcome to AP Chemistry Course. In today's video we're going to talk about ideal gas law, including molar mass. Great, so we talked about ideal gas law. If you didn't watch it, I'm going to put a small icon at the end of the video. It might be right over here. So, anyway, let's start solving. So, using molar mass solving ideal gas law problems. As we said, ideal gas law is, the formula is stated as PV equals nRT. Now let's start solving using what? You're right, molar mass. Let's start. So let's start reading the question. The question mentions calculate the volume that a 17 grams of oxygen gas, O2 gas, will occupy at the temperature of 35 Celsius and the pressure of 2.20 ATM. Alright, so those are the givens. Now, as you can tell, the first step is writing the givens down. P equals V equals N equals R equals T equals. Alright, let's start. So, it mentions that a 17.6 grams of O2, that's number of moles. Let's leave it aside. Let's put the pressure. The pressure is mentioned as pressure of 2.20 ATM. The volume is going to be given as calculated. The volume is unknown. So volume is unknown. Number of moles. Well, number of moles is given as grams. Now, in order to get the number of moles, you know, as a rule, moles cannot be, the number of N can never be in grams. It must be in moles, as we learned in the video of Avogadro's law. Alright, let's start. So, we get the number 17.6 grams of oxygen multiplied, then we're going to put 1 mole of oxygen. Here we're going to have O2, and then we're going to put the actual atomic mass of oxygen. So, the atomic mass of oxygen, because we have 2 oxygen atoms, so 16 plus 16 is 32 grams of oxygen. So, this cancels this out. We're left with this unit. So in order to do the math, we use a calculator, not to waste time. So 17, alright, so 17.6 over 32. We're going to get 0.55 moles of O2. Alright, great. So we have 0.55 moles over O2. Alright, let's erase this and keep some clean space. Because we have the units ATM, we're going to tell that for sure the volume must be in liters. So what are we going to do is I'm going to write it as 0.0821, and then we're going to have L times ATM latin over the K mole. So, because we know we have ATM, how did I know that it's going to be L? Because usually whenever we're going to have 0.0821, we're going to have ATM as a unit and L as also a unit. So, with ATM, then L is there. Alright, so temperature. Temperature is given as 35 Celsius. But is that accepted? Well, no. In Charles' law, we learned that temperature must be in Kelvin. Or in all ideal gas law, in the laws of the gas in chemistry, we need to put the temperature as Kelvin. I was about to say Fahrenheit. So we add that, and in order to do so, we need to use the small equation, which is 273.15 plus Celsius equals Kelvin. Now we're going to replace the number of T that was right over here and put it right over there. So T is going to be filled right over here. So 273 plus 35, 273.15 plus 35 is going to equal to 308.15. That's great. Not great, not terrible. Alright. So we're going to have T equals to 308.15 Kelvin. Alright, great. So let me check if the math is right, 273. Alright, nothing's wrong. Great, let's start. So, we got the known values. Now let's start solving for the unknown. In order to solve for the unknown, remember we need to recreate or assign the formula and rearrange everything. So what is unknown is the v. Now we need to put v in one part of the equation. To do so, we write p times v equals nRt. Now p multiplied by v. In order to take the p in the other side and leave v in one side, we divide both sides. So this cancels this out, and we're left with v equals nRt. I think at the end of the episode of gases, I'm going to show a quick way of rearranging formulas, just in case for the students who did not study algebra. So just in case if they didn't study algebra, then it's going to be really helpful for them to understand how to do so, because it's just simply algebra and it's simple. So we're going to use this formula. Alright, so v equals nRt and over p. Alright, so let's switch units. Switch the numbers that are there. So v equals 2 n as 0.55 moles. Let's write it down as moles. We know it's O2, but let me write it down because we don't have space. And then we're going to have R up. So great. Anyway, multiply by T. Let's put the T up. 308.15 Kelvin. Extend that. Pressure is down, which is going to be 2.20 ATM. Let's put a multiply sign here. I'm going to have the 0.0821 Latin and kmol right over here. Alright, let me remove the S from here. Alright, so just in case I don't want to miss any unit, mole, Kelvin, ATM, and the rest is on here. Alright, let's start cancelling things out. So, moles with moles, Kelvin with Kelvin, ATM with ATM, and the last unit that wasn't switched, which is going to be or cancelled, is going to be liters. Alright, that's a unit of volume, and that's a great sign that we're solving everything right. So, let's continue. Let's do the math. V equals, we'll do the math on calculator. So, V equals 0.55 multiplied by 308.15 multiplied by 0.0821 divided. Alright, we'll mess up. Anyway, 0.55 multiplied by 308.15 multiplied by 0.0821. Alright, we're going to put down 2.20, and we're going to calculate everything. The number that we got is simply 6.32 liters, because the unit right over here is liters, so we put it. So the unknown volume right over here is going to be 6.32 liters. Alright, just before we submit the value, let's just revise. 0.55 above, 308.15, great. 0.0821, let me check if that's right. Yup, and the unit down 2.20, great. Everything is correct, the math is correct, the answer is 6.32 liters. Alright, that was really simple and really easy. So, what about the question if it was missing the number of n? Now we're going to do everything as it is, so let's do so. For example, let's say the question mentions the opposite, so let's down 6.32 here. Let me just write down 6.32. And the number of moles is unknown. So, moles unknown. So, let's just solve for that. Because you know sometimes questions come in that form also, so we need to be able to solve. So, alright. So, next question. Same idea, but a different unit. Alright, let's start. PV equals nRT. The unknown digit right over here is the n. Now in order to solve for the n, we are simply going to write down n equals PV over RT. The last video I showed how we did that. We just simply took the RT, both of them, and we put them under the PV. Alright, because they're both multiplied by the n, so we can just directly put them both under. Anyway, we take this formula and we start solving. So n equals, we start switching units. Pressure is 2.20 ATM, and we're going to have the volume as 6.32 liters. Alright, then we are going to have down the RT. So the temperature is 308.15 Kelvin. Let's put the R. Now because R is down, so I put the number down, 0.0821 Latin. Okay, mole. And we start solving. Alright, so we start solving the units. We have ATM goes with ATM, cancelling the units. Kelvin goes with Kelvin. And what do you have left? Liters goes with liters. What is a unit left? That wasn't cancelled. You're right. It was moles. So that showed that we're searching for moles. That's a good sign. We're doing everything right. Let's do the math right now. So when we do the math, and we start putting the numbers down, we multiply 2.20 multiplied by 6.23. Alright, that's great. 32. That's great. And then we're going to have 308.15 multiplied by the number 0.0821. We're going to get the number or the value of, as you can tell, n equals 0.549. We run that to get the same number that we started with, 0.55 moles of oxygen. Alright, let's say the question says turn this the number of moles into grams. So they want that mass, or yes, so they want that molar mass of oxygen. So we got 0.55 moles of oxygen multiplied by 32 grams of oxygen. Let me put here an off. And then down we're going to have 1 mole, because for each 1 mole we're going to have 32 grams. 1 mole of O2. So we have 0.05 mole. This cancels this out. We're left with this here. So we multiply 0.55 by 32. We're going to get the answer of 17.58. Of course, if I just do the same thing, 32 multiplied by 0.55, we're going to get exactly 17.6. But because we had that small fraction, the answer that we got was, because it was 0.549 and it was multiplied by 32, we got the number as 17.56. But that's fine. So we got an exact number of grams, so we're not missing anything, and the n equals to 17.6 if we just put 0.55, because already we turned that to 0.55, so multiplied by 32 it's exactly as it's written here, 0.55 multiplied by 32, it equals to 17.6. I don't know if it's shown in the camera, but here it is. I don't know if it's focused or not, but it did it. So 17.6 is the number, but what about the unit? Grams of O2. That's really simple, really easy, nothing hard, and it's really fun, to be honest. And being in the world of gases in chemistry is actually fun. A lot of math and a lot of solving, but it's really fun. So this is all about our lesson for today, and I hope it was useful, and enjoy the playlist of gases. Of course, it's really important in AP Chemistry. So this is all about our lesson for today, and I hope it was useful. Have a good one.